Find in terms of pi the length of the arc that subtends an angle of 30 degree at the center of a circle of radius 4 centimeter. So here we have a circle and say we have an arc, this arc, and this is 30 degree angle. Radius is 4. So simple formula we have to use. Length of the arc is theta by 360 into 2 pi r. So this theta is 360. So we use theta is 30 degree. So we use 30 degree by 360 degree into 2 into pi. Pi, because you have to find in terms of pi. So let us keep it as pi. And radius is 4. So this is 12 times 2 6 are 12, and then we have this is 2 to the 4, 2 3 to the 6. So you get 2 pi by 3. This is the answer. Find the angle subtended at the center of the circle of radius 5 centimeter by an arc of length this much. So now the circle, the arc length is given. This one is given. This is 5 pi by 3. We have to find the angle here. So we'll use the same formula. That is, length of the arc will be equal to theta by 360 into 2 pi r. This length is given, which is 5 pi by 3. This length is given, this length. And theta is not known, by 360 into 2 into pi into r. R is 5. This 5 pi goes, and this theta will be equal to 3 into 360, and this 5 pi by 3, and we have 2 pi r we have already used, and then we have this 360, pi goes, and 360, 3 into 360 by 3 into 2. So this is 6. So this becomes 30 degree. So theta is 30 degree here. An arc of length this much subtend an angle of 144 degree at the center of a circle. Find the radius of the circle. So we again have this length of the arc is given as 20 pi, and this angle which is subtended here is 144. So we have to find out the radius. So we'll use the formula theta by 360, that is 144 by 360 into 2 into pi, this pi into r, and this is equal to 20 pi. So what do you get here? You get r equal to, this is 2 pi, this will be 2 10s are 20, so this will be 10. R will be equal to 10 into 3600, this will be 10 into 360, so 3600 by 144, and this is going to come as 25. 144 into 25 is 3600, so R will be equal to 25. An arc of length 15 centimeters subtends an angle of 45 degree at the center of the circle. Find in terms of pi the radius of the circle. So here we have an arc this much of length 15 meter, and this is subtending an angle of 45 degree at the center of a circle. Find in terms of pi the radius of the circle. So we'll keep it in terms of pi. So again, theta by this length is theta by 360 into 2 pi r. So what we will do, we have this r to be found out. So 15 into 360 by 2 pi will be equal to r. So this is going to be 60 by this 60. You have theta by 360, so we have 360 into 15 by, oh, theta is also known, so theta is 45 degree. I'll just keep theta by 360, so 45 will go down, but 360 into 15, 360, let me do it again, r equal to this 360 into 15 by 45 into 2 into pi. This is going to be 60 by pi. This is the answer. Find the angle subtended at the center of a circle of radius a by an arc of length this much, a pi by 4. Same thing we are going to do. Now in this case, the length of the arc is given as a pi by 4. Radius is given as a. So we have the length as a pi by 4 is theta by 360 into 2 pi r, right? So 2 pi r, radius is also given as a. So a pi goes here. So this theta will be equal to 360, this goes up, 4 is already there, into 2. This is 45 degree. A sector of a circle of radius 4 centimeter contains an angle of 30 degree. Find the area of the sector. So again, we have a sector, same thing, radius is 4, angle is 30 degree. We have to find out the area of this sector. Now the formula will change. Let me tell you the formula. The area of the sector is theta, which is this one, by 360 into pi r square. So theta is 30 here, by 360 into pi, we'll find it in the terms of pi, into r square. R is what? 4. So 4 into 4. So you get this, if you solve this will be 4 by 3 pi. A sector of a circle of radius 8 centimeter contains an angle of 135 degree. Find the area of the sector. So you just have to use directly formula here, because the area of this the sector of radius is given. So radius is given, this r is 8 here, and the angle is 135 degree. Just use the formula theta by 360. So I'll be putting the values directly. Theta by 360 into pi r square. So pi into r square, 8 into 8. And just solve it, it will be 24 pi. The area of a sector of a circle of radius 2 centimeter is centimeters. I'll just come to this. This is actually pi. This is pi. Find the angle contained by the sector. So in this case, we have radius as 2, right? And this area, that means this region area is given as pi. We have to find out this angle. So area, which is pi, equal to theta by 360. We have to find theta by pi r into pi r square. So pi r square, r is given as 2. So I'll just write 2 into 2, that is 4. So what do we get here? Pi goes, theta becomes 360 by 4, which is 90 degrees. So theta is 90 degree here. The area of a sector of a circle of radius 5 centimeter is 5 pi centimeter square. Find the angle contained by the sector. So here we have a circle, and the area of a sector is given this area, this region area is 5 pi. The radius is 5, and the angle needs to be known. So what is the area? 5 pi is theta by 360. We don't know the theta. Pi r square, radius is given as 5, so it will be 5 into 5. So what do we get? 5 pi goes, theta will be simply 360 by 5, which is going to be 72 degree. Find the area of a sector of a circle of radius 5 centimeter if the corresponding arc length is 3.5 centimeter. So how are we going to do this? We have to find the area of the sector. So area of the sector is simply, just have to use the formula, and if the corresponding length arc is 3.5 meter. So we have a circle here. We have to find out the area of the sector. If the corresponding length arc, so length of the arc is given here. This is 3.5, and radius is 5. So what we have to do here is, in order to find out this area formula is theta by 360 into pi r square. So we need the theta first. How to find the theta? Theta, see, L equal to r theta. That is, length of the arc is equal to radius into theta. But here the theta will be in the form of radians. What we get here is in the form of radian. That is, if I take this, if I want to find out theta, it will be L by r. What is L? Length of the arc is 3.5. So I put it 3.5. Radius is 5. So this is going to be 0.7. But this 0.7 is in radians. I have to change it into the degree before I can use it for the area. Theta is this one. This is in degree. I want to find it in radian. Theta in radian will be, we have to multiply this by 180 by pi. We have to multiply 180 by pi with this. Okay, because 1 radian is equal to 180 degree by pi. This in degree, 180 by pi, you can understand like this. So we have to multiply this by 180 by pi. So let us find out the area now. Area is what? Theta by 360 into theta by 360 into pi r square. So in theta, we are going to use this one. That is 0.7 into 180 by pi. And here we have this theta I used. Now let us put pi r square. And here we have 360. So now this radius can also be used. So radius, we can write it as 5 into 5. So 25 is here. 25. This is 2 times and you get 0.7. This is 7 into 25, 175 by 20 here you are getting, and this is going to be 8.75. So 8.75 centimeters square is the area. So the basic thing what we have done in this question is, first we are given the length of the arc and radius, so we found out the theta first, L equal to r theta, or you can say theta is L by r. And this theta is always in this formula is in radian. So we have to convert it into degree, so we multiply it by 180 by pi. Then area was theta by 360 into pi r square. We use this theta directly here and just cancel the terms and found out the area. In a circle of radius 35 centimeter, an arc subtend an angle of 72 degree at the center. Find the length of the arc and the area of the sector. So here a circle is there, and in a circle of radius, so radius is also given. This is given as 35. Arc subtend an angle of 72 degree at the center. Find the length of the arc. So length of the arc has to be found out, and the area of the sector. So what will be the length of arc? We know the formula, theta by 360 into 2 pi r. So theta is 72 by 360 into 2 into pi into r. The radius is 35. So this is going to be 44 if you solve it. And area of the sector is theta by 360 into pi r square. Theta is what? Theta is 72 by 360 into pi into r square. So 35 into 35. If you solve this, you can take 22 by 7 here. It will make the solution easier. This is going to be 7 centimeters. Of a sector of a circle of radius this much is 27.2. Find the area of the sector. Now here there is a circle, and then we are given the perimeter of a sector of a circle, that is this line plus this line plus this line. The length of all these three is given as 27.2 meter. That is, if I take this as r and r, so 2r plus, say this is the length, so 2r plus length equal to 27.2, and we have these values. 2 into 5.7 plus length equal to 27.2. So let us take this one here. Length will be equal to 27.2 minus 2 into 5.7, and that is going to come as 15.8 meter. So this is 15.8 meter length. But we know the formula of the length. Length is this 15.8 is equal to theta by 360, this theta which is not known right now, into 2 pi r. And we know that this 2 is 2, 22, we can write it as 15.8 equal to theta by 360 into 2 into 22 by 7 into radius. Radius is what? It is given here, 5.7. So theta becomes 15.8 into 360 into 7 divided by 2 into 22 into 5.7, and we can write it as 110.6 by 250.8. Then coming to the area of the sector, because theta is known now, we can write theta directly like this. So area is given by theta by 360 into pi r square. So theta will write this one. Theta will be 110.6 by 250.8 into this 1 by 360, or pi is 22 by 7. R square is this r we know 5.7 into 5.7, and then we have 360. So when we solve it, it is going to come as 44.03 meters square. So this question, this one is exactly similar to the previous one. See, there is only one difference. This 5.7 is 5.6 here, exactly similar. So what we are going to do here is we have a circle, we have the parameter, this one, and this one. So we just try to find out this length of the arc, which is going to come as 2 into this is r, so 2 into r minus of this 27.2 will be equal to length, which is 16. Then we equate it to the length of the arc because we have known the length of the arc, that is theta by 360 into 2 pi r equal to 16, which comes here. Then we find out theta like this, 1 by 0.7 pi. And then we know the area of the sector, which is pi r square, that is theta by 360 into pi r square. Theta we put it here like this, by 360 into pi r square. So when we multiply, we get 44.8 centimeters square as the answer. So this is almost similar to the previous one. A sector is cut off from a circle of radius 21 centimeter. So there is a circle and there is a sector being cut out, this center. Radius is 21 centimeter. The angle of the sector is 120 degree. This is 120 degree. Find the length of its arc. So we have to find this length of the arc and the area. So length of the arc is simply theta by 360 into 2 pi r. So theta is 120 degrees. So theta by 360 into 2 into pi, that is 22 by 7, into r, that is 21. And this is going to come as 44 centimeter. How about the area of this sector? That means this area, it will be theta by 360 again with 120 by 360 into pi r squares, 22 by 7 into r square. R also is known to us, 21 into 21, and this comes to be 462 centimeters square. A minute hand of a clock is root 21 centimeter long. Find the area described by the minute hand on the face of the clock between 7 am and 7:05 am. So first of all, you have to understand this, that a minute hand, if it is here, it will take 60 minutes to take 360 degree, to turn around 360 degree. So in 60 minutes, this minute hand moves or rotates 360 degree, right? Now this is 7 am to 7:05 am. So this is 7:05 am. This is 5 minutes. This is 7, this is 7:05. So in 5 minutes, how much angle it will cover in 5 minutes? It will be 360 by 60 minutes for 1 minute. And just multiply it by 5 for 5 minutes. And this is going to come as 30 degree. So this is your 30 degree. When the angle is known, then you can find out the area of this sector. So area is what? Theta by 360, that is 30 by 360 into pi, that is 22 by 7, into r square. R is under root 21. And if you take the square of this should be 21. So you get, see, this is 312 and you get 7 3s are 21, 3 4s are 12. So it is 11 by 2. It is going to be 5.5 centimeters square. A minute hand of a clock is 10 centimeter long. Find the area of the face of the clock described by the minute hand between 8 and 8:25 am. So we have a clock and there is a minute hand here at 8, and then we have a minute hand here at 8:25. So it's around 25 minutes. So in 25 minutes, how much angle is covered? See, in 60 minutes, this minute hand covers 360 degree. In 1 minute, it covers 360 by 60 degree. In 25 minutes, 360 by 60 for 1 minute, and for 25 minutes it will be 25. And this is going to come as 150 degree. So the angle is 150 degree. In order to find out the area will be theta by 360, so 150 by 360 into pi r square, 22 by 7 into r, that is 10 into 10. Now this is going to come as 130.95 centimeters square. A sector of 56 degree cut out from a circle contains area 4.4 centimeters square. Find the radius of the circle. So we have a sector, it has been cut out. This is 56 degree cut out from the circle. It contains, the area is 4.4 centimeters square. You have to find the radius of the circle. So what is the formula of area? This 4.4 is the area. 4.4 is theta by 360, that is 56 by 360 into pi r square, 22 by 7 into r square. R is not known. So R will be equal to 4.4 into 360 into 7 by 56 into 22, and you have to take the square root of this, and this is going to come as 3 centimeter. Area of a sector of central angle 200 of our circle is this much, 770. So 770 centimeters square is the area, and 200 is the angle. So let me make, well, it is already been made, but let me show you that. So this is 200 degree. So theta is 200 degree, and the area, this area is what? It is 770 centimeters squared. We have to find the length of the corresponding arc of this sector. So length of this one we have to find out. So length is what? See, area is known. So first we will put it here and find out the radius. So area is 770. So 770 will be equal to theta by 360, 200 by 360 into pi r square. That is 22 by 7 into r square. So r square will be equal to 770 into 360 into 7 by 22. 200 into 22, we have to take the square root to find r. R will be equal to 21 centimeter. Now in order to find out the length, what we will do? We can directly use the formula theta by 360 into 2 pi r. That is also an option. But there is one more option, L equal to r theta, or you can say theta equal to L by r. Now this theta is L by r, but this L and r, this will come in the, this formula use the radian. So this is radian. So in order to find out this one, see, first of all, this L equal to r theta, we have to find out the length of the arc. So it will be r, radius is what? 21, and theta is what? 200. But this 200, this formula uses not in degree, this is in degree. We have to use it in radian. So how to convert a degree into radian? 1 degree is pi by 180 into pi into 180 degree radian. So you just have to multiply this by pi into 180, and this is going to come as 73 1 by 3 centimeter. This is the only thing. Otherwise, if you wish, you can just use this formula, theta by 360, that is 200 by 360 into 2 into pi r, 22 by 7 into r. Radius is, of course, we just found out it is 21. So you can use this formula, same thing is going to come. The length of minute hand of a clock is 5 centimeter. So here is a minute hand and the length is 5 centimeter. The area swept by the minute hand and during the time period 6, 5 and 640. So we have to find out, this is 6, 5. So here is the minute hand, and then we have 640 here around this one. So we have to find out, first of all, we will find out the area, the angle, that is not a problem. But we have to find out this area, and the area. So this area we have to find out. So as I said, this 6, 5 and 640, 40, how much difference is there? That is, it is 35 minutes. So for 60 minutes, it takes 360 degree. For 1 minute, it takes 360 by 60 degree. And for 35 minutes, it takes 360 by 60 into 35. And this is going to come, this will, we can directly use. This is 6 into 35. 6 into 35 we are going to use directly. Now this is the minute hand revolving. We have to find out the area. Area is what? Theta by 360 into pi r square. So theta is what? Theta we just found out. This is 6 into 35 by 360 into pi, 22 by 7 into r square, that is 5. 5 into 5. And this is going to come as 45, 5 by 6. This is the answer. The length of a minute hand of a clock is 14 centimeter. Find the area swept by a minute hand in 5 minutes. So minute hand, 60 minute it takes to revolve 360 degree angle. 1 minute it's 360 by 60. For 5 minutes it will be 360 by 60 into 5. This is 6 6 is 30. 6 6 is 36. So it is 5 6 is 30. 30 degree we are talking about. So we'll do what? Before saying thanks, let us just first find out, it will be theta by 360, that is theta is 30 degree by 360 into pi 22 by 7 into r square, 40 into 40. So what do we get? This is theta by 360, right? So we will find out here. First of all, 6, this goes 6 times, 7 2s are 14, 2 3s are 6. So it will be 22 into 14 by 3. You can just multiply 22 into 14. So it will be 88 and 22, 8, 0, it is 308. So 308 by 3. You want to write it in some other form, this will be up to you. 2. So in a circle of radius 21 centimeter, an arc subtends an angle of 60 degree at the center. Let me make it first. So an arc subtends an angle of 60 degree. This is 60 degree as you see here also. This is 60 degree and this is 21, which is the radius. Find the length of the arc and the area of the sector. So we directly have the formula, that is length is theta by 360 into 2 pi r. So theta will use 60, theta by 360 into 2 into pi, that is 22 by 7 into r. R is also already given 21 and this is going to be 22 centimeter. Then we have area of sector. Area of sector. So area of sector directly formula we have. Area is theta by 360. Let me write the values directly. 30 by 360 into pi r square. So 22 by 7 into r square, that is 21 into 21. So this will come as 231 centimeter square. This will be in the centimeter square. This will be in centimeter. From a circular piece of cardboard of radius 3 centimeters. So there is a circular piece of cardboard. The radius is 3 centimeter. 2 sectors of 90 degree. That is 2 sectors. See, this is 90 degree sector and this is another 90 degree sector. So 1, 2. These are 2 sectors being cut off. So half of the semicircle means half of the circle is taken off. So only semicircle will remain. Now here we have to find the perimeter. We have to find the perimeter of the remaining portion nearest to 100 centimeter. So what will be the perimeter? Perimeter will be, the remaining will be this one. So we'll find out this part and this part and we add them. So what is this part? See, 2 pi r is the circumference of the circle. When you make it half, it is 2 by 2 pi r. So it will be pi r only. Half of 2 pi r is pi r. So it will be 22 by 7 into radius. What is the radius? It is given 3. So this will come as 9.428. But in order to find out the perimeter, we have to add this line also. This will also come in the perimeter. So what is this? This is 3 and this is 3. So diameter we have to take, which should be 6. So 6 we have to add. So 6 plus 9, that is 15.428. This will be the perimeter of the cut-off portion or the remaining portion, you can see. The area of a sector is 1/12 that of a complete circle. Find the angle of the sector. So the area of the sector, say this is the sector. This area of the sector is 1/12 that of the complete circle. So area of the sector is 1/12 of the complete circle. What is the area of the complete circle? It is pi r square, right? So this area of sector, we can use the formula also. So we'll equate this to that formula. That is 1/12 of pi r square is actual formula we know. Theta by 360 into pi r square. So that will be theta. First we have to find out the theta can be found out like this. Theta by 360 into pi r square. This is the area. And this is given that it is 1/12 of the pi r square. So what will happen? Pi r square will get cancelled. Theta will be equal to 360 by 12 and this is going to come as 30 degree. AB is a chord of a circle. So here AB is the chord of the circle and center is O. Radius is 4 centimeter. AB is of length 4 centimeter. So this is 4 centimeter. This radius is also 4 centimeter. So all the sides of this triangle being formed, that is ABO or OAB, you can say this triangle has all the sides equal. That means it is an equilateral triangle. Find the area of the sector of the circle formed by the chord AB. So we have to find the area of the sector. So this area we have to find out. So first of all, the only thing is this angle we have to know, and we know that for a triangle which is an equilateral triangle, all the angles are 60 degree because the sides are equal. So this angle will be 60 degree. So we'll just use the formula, find the area. Area is theta by 360. 60 by 360 into pi r square. Pi is 22 by 7, or you can use it pi also, into r square, 4 into 4. This is 6, so you have 2, 3. So this is 8 pi by 3, you can write like this also. Centimeter square unit. In a circle of radius 6 centimeter, the chord of 10 centimeter, this is a circle, a chord of 10 centimeter makes an angle of 110 degree at the center of the circle. Find the circumference of the circle. The circumference is simply 2 pi r, that is 2 into 3.14 into r, that is 6. So this will come as 37.68. Then we have to find the area of the circle, that is pi r square. So 3.14 into r, that is 6 into 6, and this will come as 113.04 centimeter square. What is the length of the arc? Theta by 360 into 2 pi r. So theta is 110 by 360 into 2 into pi into r, that is 6. So this will come as 11.51. And how about the area of this sector? That is theta by 360 into pi r square, 3.14 into 6 into 6, and this is going to come as 34.54 centimeters squared. This figure shows a sector of a circle at center O containing an angle theta. So we have to prove this. That perimeter is this one, and area of this shaded portion is this one. So the perimeter is what? Perimeter of the shaded portion will be this one, and this portion. So we have to find out the length of the arc, this portion and this portion. So this is what? This is a tangent. This is a tangent to the circle. So this angle will be 90 degree. This angle will be 90 degree. Okay. So this is theta. So you will use the first we will try to find out this AB. So AB will be what? AB. I'll use the tan theta for this triangle. That is this triangle. OAB. I am taking this triangle. Tan theta will be perpendicular AB by base, which is OA. But OA is R tan theta. So AB will be equal to R tan theta. AB we got. So one side we got for the perimeter. And then we have to find out this side. And this side, how you are going to get this? For that you have to find out the area. See, area of a triangle is what? Half into base into altitude. So area of this triangle will be half into OA into altitude. That is this AB. So we will find out the area of the shaded region first. Means we have to start the basement. So this is half. What is this OA? This is R. And what is this AB? Which is R tan theta. So area of this triangle is R square tan theta by 2. This we got. Okay. Now, what is the length of the arc? Because one line AB we already got. We have to find out first this one and then this one. So what is this side? This length of the arc. Length of the arc is simply L. Length of the arc is theta by 360 into 2 pi r. So theta by 360 into 2 pi r. We can write it as 2 into 180. So we can write it as pi r theta by 180. So this also we got. This we got. Now to find out the perimeter, as I said, we have to find this AB, AC and BC. So what will be this BC? What will be this BC? See, I'll use now this triangle. This is theta. So I'll use what? I'll use this cos theta. What is cos theta? Base upon hypotenuse. So this is R. Hypotenuse we have to find out. Base upon hypotenuse. So R by hypotenuse. So R will be what? This hypotenuse will be what? R by cos theta. And this will be R sec theta. So this whole is R. OB is R. This whole is R. And the OB is not R. This OB we have to find out. Sorry. And what is this OC? This is R. So what is this OB? OB is nothing but OC plus BC. OC plus BC. OC is R. BC we have to find out. So this BC will be OB minus OC, that is R. OB minus OC. And OB is what? We just found out it to be R sec theta. R sec theta. So it will be this portion BC, which we have to find out, this one. This BC will be equal to R sec theta minus R. Okay, OB we have put R sec theta minus R. So we have this now, R sec theta. So this R sec theta minus R we have. Then we have this length of the arc. We just found out length of the arc to be pi R theta by 180. And then we have this line AB. AB was what? AB was R tan theta. So R tan theta. Okay. Now I just take R outside. What do you get? This will be, I'm taking first this one, tan theta. Then I'm taking this one, sec theta. Then I'm taking this one plus pi theta by 180. And then this minus R. R we have taken, so minus 1. So this is what is the perimeter, and this is what we have to find out. This we have to prove. So we have proved the first one. Now area of the shaded region will be what? Area of the sector minus whole area. We have already found the area of the triangle. Now we just have to subtract. We have to just subtract this area of sector from here. So this is R square tan theta by 2 is the area of the triangle, and subtract the area of sector, which is, sector is what? Pi R square theta. It means theta by 360 into pi R square. So you just write pi R square theta, theta by 360. Okay. Now take R square by 2 common. R square by 2 common. So when we take R square by 2 common, here we have only tan theta. Here R square by 2 we have taken common. So this will be 2 into 180. 2 we take common. So only remaining will be pi theta by 180. So this is the second thing which we have to prove, which we already proved, right? Now we have a figure shows a sector of a circle of radius R. So this is R, this is R, containing an angle theta. The area of the sector is a centimeter square. The area of the sector is a centimeter square, and the perimeter of the sector is 50 centimeter. Perimeter of this sector is 50 centimeter. Now we have to prove these two. So area of the sector is what? See, we know area of the sector is theta by 360 into pi R square. This we know. So what is the perimeter? Perimeter is given. It is 50, and which is equal to this R plus this one. So R plus R is 2R plus this length of the arc is theta by 360 into 2 pi R. Theta by 360 into 2 pi R. Right? So just keep this theta here and put this on this side. So this will be 50 minus 2R. 2R. This will be equal to theta by 360 into 2 pi R. So in order to find out now the theta by this theta, what we have to do? We take 360 up, 360 into 50 minus 2R. This we have taken up, 2 pi R we are taking it in the denominator. Now 360 by pi we are taking out, so 360 by pi, rest we are taking inside. So 50 by 2R, pi we have already taken out, so 2R will go here and this 2R by 2R. So what do we get? 360 by pi. And this will be 25 by R minus 1. So this is the first thing we have to prove. Now coming to the area. So area will be, area of the sector we already know. Area of the sector we already know. This is equal to theta by 360 into 2 pi R. But if you see here, I said theta by 360 is 50 minus 2R by 2 pi R. So in place of theta by 60, I can write 50 minus 2R by 2 pi R. So 50 minus 2R by 2 pi R. Theta by 360 into 2 pi R. Or you can say that this theta by 360 or theta by 360, if you see, I can write it as 25 by from here. So because we have already solved it, this is equal to theta. So theta by 360 is 25 by R minus 1 by pi, right? This one. Now we have to, this theta by 360 into 2 pi, theta by 360 into pi R square. So this theta by 360 we have written as, and 2 pi R is already there, pi R square, sorry, pi R square into pi R square is already there. So pi cancels. Now take this R inside. 25 by r into r square minus this r square. R cancel, this will be 25r minus r square. This is the second thing we have to prove.